Hello. Today we discuss these three theorems and move on with the factoring of polynomials and finding zeros. Previously, we have been discussing polynomials, basic things with the polynomials, zeros, multiplicity of zeros, and things like that. And then the last where we left was that the remainder theorem, which tells us how to find a rational zero of a polynomial. So we are going to look at these three theorems because they are going to help us factor out the polynomial and find the zeros of the polynomial. And so I repeat rational zeros theorem here. So it says if p of x is a polynomial with integer coefficients, and if p of over q means is a rational zero, I could just say k here, but we mean to say that k is a rational number, means k is something of the type 2, -5, 2 over 3, something like that. So then that if there is a zero that is of this form, then it must be that the p is a factor of the constant term and q is a factor of the or divisor of the lead coefficient. Okay, and the remainder theorem, it says that if the polynomial p of x is divided by a linear polynomial of the form x minus c, then the remainder is the value of p of c. Okay, if we divide a polynomial by x minus c, and if x minus c, you know already x minus c is a factor of the polynomial, the remainder will be 0. And if it is not a factor of the polynomial, then there will be some remainder which will be a number, because the remainder has to have a degree less than the degree of the divisor. So the degree of the divisor here is 1. So the remainder must be of degree 0. 0 degree is used for constant terms or the numbers. They are polynomials of degree 0. So here we are not going to prove these theorems, but I'm going to show you how this remainder theorem, what it means. So let's take a polynomial x squared minus 3x minus 4. We already know that it can be factored as x squared minus 4 times x plus 1. So let's say if I divide it by x plus 2, so which means my c is equal to -2. So I divide here and I am getting a remainder of 6 down here. Now if I take the c value and plug it directly in the polynomial, so find p of minus 2 and plug in polynomial, I end up getting a 6. So note these two are the same. That's what the remainder theorem is saying. So it says that if you want to find the remainder of the division, sometimes it will happen, and actually in this section in a few minutes we will see the examples, that we want to look at the remainder only. We are not worried about the quotient or any other process in between. We want to see what the remainder is. So then we can directly plug in this. But this only works when we are dividing by x plus c type or x minus c type of polynomial, not like something x squared plus 2 or x squared plus 3x plus y, not even 2x plus 3 or 2x minus 3, specifically by x minus something. Okay, now here I am going to divide the polynomial by x minus 4. We already know that x minus 4 is a factor of this polynomial. So if I divide by x minus 4, I am expecting a remainder of 0. And I divide, and there you go, I found the remainder is 0. And now if I plug in 4 directly in p, I see that I get a 0. So this is what we want to do. We want to find a number. That will be our goal. We want to find a number which, when plugged in the function in the polynomial, gives us 0. Okay, so let's see. The third theorem is factor theorem. So it says a number c is a 0 of a polynomial p of x if and only if x minus c is a factor of p of x, which is true. Now, what we are going to do basically here is going backwards. So when you are solving a quadratic, for example, so if you have a quadratic way like I just wrote, so x square minus 3x minus 4 equal to 0. So the next step is x minus 4 times x plus 1 equal to 0. Then you say it means x minus 4 is 0 or x plus 1 is 0. Yeah? Or you say that x minus, because x minus 4 is a factor and x plus 1 is a factor. So from there you say x is equal to 4 or x is equal to 1, negative 1. So now we go backwards. We start here. We say x is equal to 4, means x minus 4 is a factor. And x is equal to negative 1 means x plus 1 is a factor. So then you multiply both. So you can say my p of x is something like this. So we are going backwards. Okay, that's what the process we will do. So this basically, when this statement if and only if, this is kind of important, if and only if. So it says it works both ways. If x minus c is a factor, then p of c will be 0, or c will be a 0 of the polynomial. And if c is a 0 of the polynomial, then x minus c is a factor of the polynomial. Now with the aid of these three theorems and with the complex numbers that we reviewed previously, we can actually factor out and find the zeros of polynomials of degree higher than 2. Note that the factor theorem gives us a relationship between zeros of the polynomial and the factors of the polynomial. So if a polynomial p of x of degree n has zeros, real or complex, k1, k2 up to kn, then we can write p of x as x minus k1, x minus k2, and so on, up to x minus kn. Now, another thing to note here is that there is actually a theorem, maybe you will see it later, which says that if a polynomial, you have a polynomial of degree n, then that polynomial can have at most n real zeros. It can have n zeros in all. Okay, n zeros in all. So real or complex, not more than n. You cannot. A polynomial cannot have zeros more than its degree. So if it's a cubic polynomial, it can have 3 zeros, 2 or 1 real zeros. But in total it will have n zeros. Okay, in total it will have n zeros, real or complex. But if you just count the real zeros, then real zeros can be 3 or 2. No, it cannot have 2 actually. If it's a cubic, it will have 1 real zero or 3 real zeros, because the complex zeros, they appear in pairs. So it cannot have 2. You cannot have 3 real complex zeros, or cannot have 1 complex zero. That you will see when we do the examples. Okay, so let us move on. So now we know that if we have that 4 is a 0, then we can say x minus 4 is a factor. But what if we have 0 is negative 2 plus 3i? So how will you write the factor for that? So the same way, you will say x minus the put this zero as in within the bracket so that we do not mess up the sign, and then just distribute the sign like in algebra, so you get your answer. Okay. Next thing is multiplicity of a zero. So remember, the multiplicity you already know from before. It is the number of times the factor x minus c appears in the fully factored form of the polynomial. So the zero, if your one of the zero is called c, then how many times the factor x minus c appears, and then you can put it on as a power. So if it is appearing, for example, if you have a factor x minus 5 and it appears 3 times, you can write it x minus 5 to the third. So the multiplicity of the 0, 5 is 3. Okay, I will think we will discuss the rest in the next video.